So, my name is Maciej Wyrodek. I am working at Objectivity. I am community leader of test automation community, which basically means I'm teaching people how to automate, I'm doing code reviews for them and that kind of stuff. I have also a blog called The Block and Test, and in my free time, I'm also writing some different codes on the GitHub and putting it on NuGet or other stuff. Today, here I am with the subject about how Selenium finds element. So, two things. I won't give you any tips. This is basically about your curiosity, to show you how the stuff works under the hood. And I don't have any tips for you. If you want some tips, there are better presentations for that than about the working of the machines. But I like the quote from Jackie Stewart. I don't know if it's any connection to the Simon. Basically, you don't have to be engineer to be good racing driver, but some machine sympathy goes a long way. And I think similar, knowing how the stuff works can be quite useful from time to time. And my story about going into deep of the Selenium started in 2014, because I was working with automation for a few years, and I was leaving one company. My last job there was to create a POC of automation. And the guy who was taking over from me, he had some ideas. Basically, when we came to the selectors, he said, let's use XPath for everything. I was, what? No, I see a lot of problems with this. He said, dude, chill. Basically, they all work the same way under the hood, and XPath is giving you the most option. You can find, for example, by the text. If you think for a moment, you realize there is contradiction here. How they can work the same if XPath is giving you the most options? So, when I was taught how to use Selenium, someone taught me that first you should use ID. If you cannot find ID, go for the names or classes. Then CSS selector, then XPath, and then at the end, link text. There is some error here. I will talk about it later, but this is how I was taught, and back then, it made sense to me. So basically what we did what every engineer is doing in that situation. We started to experiment. So we decided to test how this stuff can work. And the simplest way for us was to use the code we already had written for the POC and see how the stuff is working. Basically, being young and foolish, we said, let's measure the performance of different locators. If there will be a visible difference there, something is on that they are not working the same. So what I have here is some shitty code. Please don't write automation this way. Basically, I have some setup, and then I'm using different locators to find a stuff on some stupid page. And then I'm doing some measurements and doing calculation based on it. Let's run it. OK, so as it will be running, the browser will be opening. Of course, the times we will get today will be completely different than the times we are getting in 2014. The biggest difference is we are using Internet Explorer 8, because that was the mandatory browser for us. Why I'm not using Internet Explorer here? Because I hate it, and I'm not going to spend any time working on it if I can avoid it. And so what I'm doing later, after I finish collecting my times, I'm doing, I can't catch it. Yeah, now. I'm doing some calculations and writing them down to log files with what is average time, what is minimal time, what is max time. If you know anything about performance, you probably will say that I'm doing quite a lot of things here that are wrong from the performance measuring side. But the goal of it was simple, to see how the stuff is working and what's going on with the times there. Let's finish the last one. OK. Is it done? Now it's done. So, OK. So I have different times for different browsers, for the different locators. And now, being a lazy guy, I spoiled the surprise. I hope it will work there. We decided to make some measurements there. Of course, using the logger for collecting information makes it a lot of useless data there. Let's cut it, a little of it here. Replace all. So, the times, as you see, are not the drastic difference between different locators. That is now. Back then, I was seeing much more difference in the time, especially with the XPath. That was something like twice or 3 times as high than anything else. But my friend wasn't fully convinced by that. He said, what I already told you, that this is not proper test. We are measuring quite a lot of stuff there. We are not using a proper selectors. Those are very simplified stuff. We are not seeing anything here. So we need to go deeper. What we actually did there, we started looking at the logs of the driver to see what's happening there. But let's be honest, logs are boring. We're going to play with Postman instead. Because as Simon said today in the morning presentation, basically, our bindings are using REST API to talk with the browser. So let's put it on. OK. Is the Postman window visible for you? OK. So, oh, sorry, this is the last one. This is the start. If you want to create browser, you have to send the capabilities you want to run. In this case, it's Chrome. And what happens? It opens as the Chrome, and it's sending the information response. Since this is REST API, it means it's stateless. So basically, server doesn't care about us. So we have to do everything. In this case, if you want to do something with that window, we have to send our ID. I was lazy, so I put it already in some parameter. And we can go to URL. And here was thing when we were looking that was a little more surprising for me. So if you want to find element, we have to send using information and its value. In this case, I'm using ID because it's still supported for now, and the value what I want to find. That was also the place when we were looking at the logs that said to us, OK, if they are the same, they are not at the level of the bindings. Maybe somewhere deeper inside makes them work the same. But at that point, I wasn't fully aware how everything is working in Selenium, so I didn't know that what we are getting back is some ID. We are not getting actual element. If you want to get some more information, we have to ask for the specific things, like get the text. When I realized that, it made a lot of sense, because I always was curious why, when I'm opening the debugger, I'm looking at the element, I have to wait some time before the Visual Studio will have all information I'm needing. Now, after doing this, I understood it is calling each separate information to get there to show me. And we can close it. OK. But doing it wasn't everything. We decided also to take a look at the code. What's going on? Sorry, this isn't wrong window. So we have downloaded the code of the Selenium, and we are looking what's going there. Remote Webdriver. Basically, for our Chrome driver, Gecko driver, etc. code, the remote WebDriver class is the point where the most information lies, including the find element. Find element. Sorry. Oh, here it is. Okay. Okay, this is what happens when you try to do something out fast. You don't see the stuff you want to do. Anyway, there is here a find element functionality, which basically is using by, which then in that version of Selenium is going to use the interface called find element by. And this interface has the implementation of the method. And what was interesting for me in that version was that it made us go whole round way, because the remote WebDriver then had, sorry. One second. Too much code at once. Yeah, right one. And basically, it is implementing the interface. I find the element. The interface we're talking. And this is used here. Oh, finally. Okay, now I'm a little screwed up because I'm not in the place I wanted to be. Happens. Okay, so basically what's happening there, fortunately I was expecting that at some point I'm going to screw up, so I have the copy also on my slide. Basically what's happening there at this point is, if you are using the specification, we are using the CSS selector and we are escaping it. If we are using the, we are not using the specification, we are using the ID. In the current master, which is from Selenium 4, the alpha, it's no longer this way. That method is obsolete, and in by, it's done it a little differently. Since I'm currently screwing up with the showing the code, I won't be showing it right now. And let's disable it. But when I was doing originally the research in 2014, it was looking like that. There wasn't anything yet about the specification. This is now. At that time, my friend said, okay, I give up, you are right. But you know what? You are leaving this company, so I'm still going to use XPath. His choice. What I learned, it wasn't really happening like that. He wasn't using XPath because he also left the company soon after. But for me, it wasn't the end of the journey because I still don't know how it works. I decided to go a little deeper and look into the code of the Chrome driver. Here's the problem. My C++ is rusty. It's really rusty. I wasn't using it since my studies, so what's going on there is a little too complicated for me most of times. But what I found here interesting is, again, this is a new version, so we have here the stuff for the WCC compliance. And the atoms. I remember the atoms that when I was learning about Selenium, they were mentioned quite a lot, but I never paid attention too much to them. So, okay, let's go deeper into the stuff, and I wanted to see what's going on, which means we have to go into theory land. Now, that was the part, fun, full of adventure, and me screwing up. Now we are going into the most boring part. We will listen about history. In 2004, Jason Huggins created Selenium. Basically, back then there were two browsers that were popular, Internet Explorer 6 and Firefox 1.5, 1.6. His team had no testers. They had unit tests, but they had an issue. Every time they fixed something in one browser, the another failed. So Jason got pissed off, took some time, and wrote Selenium. But here is also the first important thing about Selenium. As he said, Selenium tool started as developer tool by developers for developers. And it was cross-browser testing tool. What happens with it now? I'm going to say we have strayed quite far away from what is originally meant to be. And of course, play on words. Selenium is a cure for mercury poisoning. Anybody heard about a company called Mercury Interactive? Yeah, they heard. Some other heard too. But I think about this product everybody heard, HPQTP. According to Wikipedia, Mercury was bought by HP, and the tool was renamed HPQTP. And probably everybody here who is in testing more than a few years at least heard the nightmare stories connected to using that tool. So Selenium was kind of simple. It was basically a bunch of scripts run by a remote server. You could have your own bindings in the code, and the scripts were run by the server. Problem was they had the issue with the cross-site scripting, so you could have security problems there. Somewhere around the time, another great man came into the picture, Simon, and he came with the Webdriver. The name is not as clever as Selenium, but at least it's much more descriptive. Basically, in test doubles, you have two most important ones, drivers and stub. If your code is the active one and you want to act on something, you can use stub as the replacement. But when your code is the one that is acted upon, you usually use drivers. So in this place, we are replacing the most brittle and annoying part of the system, which is user. So the Webdriver, the name is kind of fun. Also, somewhere there comes the atoms, the feature, the small feature, atomic actions connected to the browser that were performing different actions. Yeah, there are still, as you can see in the Chrome code, there are not the same one as were back then. If I understand correctly, back then there were kind of JavaScripts, now they are native. But then 2007 happened, and Simon and Jason had a nice talk called A Knife Fight in a Steel Cage, which is the most misleading title ever because they didn't have fight, they didn't were using knives, and there was no steel cage. But they both were talking about their different products, and the goal was to see if they can work together. So what happened next? They joined forces. What happens from connection of the Simon and Jason? We got Simpson albo Jamon. Unfortunately, they didn't using the Dragon Ball naming system, and they named their product either Selenium 2 or Selenium WebDriver architecture. It had the best of both worlds, the bindings of Selenium, the nice API protocol from the WebDriver, the native systems from the WebDriver. And if you look at this picture, one thing gets clear. Selenium doesn't find elements. It basically asks politely browser to give it them. OK, we talk theory, but we still don't know how it works. What's going on inside there? Well, if you are not sleeping yet or not living, then this is the time where it's getting really boring. We are looking into documentation. I am dyslexic. I love math. But when I was studying, the hardest part for me was all the definitions. Using it, easy, but trying to understand definition was always hard for me. And going to the documentation of Selenium, W3C, it's similar experience. Basically, just listen to this. The find element command is used to find an element in the current browser context that can be used as the web element context for future element-centering commands. It's a mouthful. What it's saying? In short, if you find element, you can use element. The problem is you cannot say it that way because human language has a lot of ambiguity. And this is documentation that has to be final and have all answers. So each word here has one and only one meaning. And unfortunately, as side effect, it makes it quite mouthful to read. But what is interesting there is a section about the different selector strategies. Of course, since this is W3C standard, we don't have the ID, we don't have name, and we don't have the class. But those 5 strategies are displayed there and explained how they are working. Basically, all of them are using DOM functionality. In case of CSS selector, we are using query selector all, and we are parsing our selector there. Similarly, it is for linked text and partial linked text. Difference is here that after you are finding the elements, we are looking still for the text. I won't go into all details, but this is the whole table of different actions. So ID, name, and class are translated to CSS selector, so you get it here. The one case different is the XPath. XPath is dark magic. It's actually using completely different mechanism. And literally, every time you are trying to use it, your computer is sacrificing a kitty. So now, this part made a lot of more sense for me. But I have still no answer for this slide. And there is one thing that we are bad at in IT, giving sources. I tried to find where this information comes from, that way I was taught. I found many blog posts saying something similar, but none of them is giving any source. I think I finally found it. In the documentation for the Selenium, there is such piece about different strategies. This is for, I think, Selenium 1. Notice there is no order here. There is just examples. But my bet is something here got lost in the translation, and someone was trying to treat it as the definite order. Thing is, everybody will say that ID is the best option, as of the order of other element, it's much more discutable. So, Selenium had the JSON wire protocol back then, which supported the class name, the ID, the name. And as Simon was talking today morning, that protocol is gone. Now we have the W3C Webdriver protocol, and it doesn't support them. But OK, we still don't know how the stuff works under the hood. What's going on there when we are getting the element? So different browsers are doing it differently because the goal of the documentation, the W3C protocol, was to give them full freedom. How do you find this element? How you're going to communicate there? Do it your own way. It only has to do according to documentation. So Chrome is using DevTools protocol, which I'm still calling the Chrome debug protocol because it was previous name. And Firefox in Gecko has protocol called Marionette. I'm not sure about the DevTools protocol, how it came to be, but I'm pretty sure that Marionette has a lot to do with the Selenium WebDriver, because even in the documentation, they're still saying that there are still atoms that they haven't replaced. So originally, it was basically a collection of the atoms from Selenium. But I tried to go into the code of the browsers. Chrome is in C++. Firefox is in Rust. Both were too complicated for me, so I went to my friend, front-end developer. How do you deal with this? He looked at me. He smacked me once. He smacked me twice. And said, why do you even bother? Do you know how the C# is working? No. So why are you asking me how it's working? What is important, we know which features are working how in different browsers. There is site, can I use it? Go there and see what's going on there. He was kind of right. But I am tester. I don't believe developers. So I found a nice article from 2011 about how different browser works. It's a little dated, but there is still lots of important information. Basically what it states, the browsers, the most important part is rendering engine. And currently at the market, there may be two and a half. There is WebKit, there is Blink, which is fork of WebKit, and there is Gecko. There is nothing else. And basically how they are working, they are parsing the HTML to create the DOM tree. And what we are doing, we are operating at this DOM tree that they are creating. So he's kind of right. Now, this is how the flow kind of looks for Webdriver. I have links to all the materials in the sources of my slide if you want to look them. OK, so now, believing him a little more, I went for the query selector or page, and I tried to find out how it's actually working. What I noticed here, he's right. From the browsers I have contact with, the only Internet Explorer 8 is not supporting fully the CSS. But what you can see, in past, it wasn't as nice. The Firefox and the other browsers for a long time didn't have any support for the CSS stuff. OK, so I'm not going to look into the code of the browsers, but I still wanted to know how it works. So DOM has an interesting documentation. There is a lot of information there. And there is also how the query selector works. Basically, it's parsing the selector using the parser. And if it finds anything, it throws. If there is error, it will throw it. Otherwise, it will return what it found. How the parser works? This is a little more complicated. But when you go to the bottom of it, it's kind of this weak. What you see is what you get. So if you know how the CSS selectors work, the result of the parsing should be the one that you are expecting. The XPath is actually a much more interesting one. As you can see, no Internet Explorer is supporting the XPath. And probably some of you who were using the XPath with the Internet Explorer. Here's the problem. The XPath is injected by Selenium there. And now it's kind of working, but back then it was really problematic. I'm not going to go with how XPath is working. The documentation for XPath is twice as long as the DOM documentation. OK, so now knowing this all, can we do something better than I've done it at the beginning of my slide? Can we check the performance of the different locators without the all additional adding? There is a nice site called jperf, which allows us to do exactly that. Basically, it measures operations. So I found that someone was doing some comparison between query selector all and the get element by tag name. So I modified the test a little to see how it's actually working. I'm trying to find this item here. The difference is I was measuring it in seconds. This one is measuring the operation per second. So the different operations take different time. OK, there is get element by tag name. We are left with query selector. I have done 3 attempts at query selector all. I'm looking at just the structure of the DOM. I'm trying it by ID, and I'm trying it by the class name. What we can find here is that the get element by tag name was the fastest, and the XPath is the slowest. Of course, we have also Internet Explorer, and so let's see what happens here when we try to use XPath. Error, not supported. OK, now we are on the tag name, query selector all ID, and class name. So again, tag name was the fastest, query selector all this time was the slowest because XPath had an error. Because I said the Webdriver is injecting the stuff there. So being a guy who has a little too much time on his hands, I have decided to try it on different browsers, in different configurations, on different systems. Tag name was usually the fastest. The interesting thing was that XPath wasn't always the slowest. That was the part that surprised me about Edge. OK, again, is that information for you worth anything? To be honest, no. I don't see any of you using thousands of the locators in one test. But if you want to save some time, maybe it's worth thinking about. Okay, so summing it all up, my friend at the beginning was wrong, but now he's kind of getting right because the more of the stuff inside is kind of going to query selector all. Selenium don't really find element. It's just asking the browser for them. And after you remove all the stuff in the middle, basically there is DOM. OK, that's all from me. Any questions? OK.
So practically, after you ran all those analytics, to which method did you settle and why?
One more time.
So after all these analytics, in a practical way when developing tests and all, to which method did you settle?
Usually, I'm doing two things. If I can, I'm using ID. If not, usually I am using, in reality, the CSS selector. Basically, we are using data attribute. If data is it's clean from perspective of the browser. You can use it to create your own attributes, and the browser will be ignoring them. They are used mostly for the storing data purposes. So we usually have something like data ID, data locator, and we're using it as the logic for finding elements. And when you use it, you're usually using CSS selector because you are using CSS find by attribute. But whenever I can, I'm using ID. IDs are the cleanest, in my opinion. Problem is, developers are not using IDs anymore. If you look at the stuff, they are using some auto-generating stuff like Rect, Angular, Material, what else is there? There are a ton of different stuff. And they don't have as many IDs there anymore. Basically, that's why I'm trying to force them to write code, because when when they see that they don't have that, they usually think about adding something. Did I answer your question? OK. Anybody else? OK, just in case, you can find later me here. Thank you for your time.